In this video, we are going to do questions of square and square roots and cube roots. Now, the questions we are going to do in this video are, these are the questions we'll be doing. A question from cube roots, these are square roots. Below I have taken some MCQ based on, not MCQ, yeah, we have MCQ like these true false questions, and yes, we have MCQ also. So there will be some 15 to 16 questions we'll do in this video. So let's begin with the first one. Now in this question from the cube root, it says if cube root of 0.512 over x is equal to cube root of 1 followed by 6 zeros, then what is the value of x? So what we are going to do is to simplify the left hand side. In the numerator of left hand side, we have to get the cube root of 0.512. So first of all, you have to get the cube root of 512, which is 8. And you know that for every 3 decimal place, there will be 1 decimal in the cube root. So we realize that 0.512 can be written as 0.8. Now, if I replace this with 0.8 over x is equal to, now cube root of 1 is what? 1. And we know that for every 3 zeros, there is 1 0 in the cube of this. So I can write this as what? 1 0 for this 3 and another 0 for this. Now here we'll do cross multiplication. 100 multiplied by x is what? 100x, and this is equal to 0.8. Further, we know that we can get the value of x by dividing this 0.8 with 100. That results to give you, that the decimal will shift 3 decimal for these 2 zeros, 2 decimal left. So it will results to give you 0.008. So we can say that the value of x over here is 0.008. That should be the answer in this case. Now in this question, we are given that if under root 1 plus x over 144 is equal to 13 over 12, then what is x is equal to? Well, to get the value of x, the first thing that we need to do is to remove this square, and that's possible if you do squaring both sides. So this is what we are going to do in the first step. That means over here we'll be doing squaring both sides. Now we know that on squaring a square root, right, the square root vanishes. That means on the left hand side we'll get what? 1 plus x over 144 without a square root, right? As I told you that the root will get vanished. On the right hand side, as you know that the square of 13 is what? Square of 13 is 169 and square of 12 is 144. Now first thing we are going to do is to transpose this 1, right, this number 1 to the right hand side. So let's say if I do it over here, that is keeping x over 144 on the left hand side, this is 169 over 144 minus 1. I'm transposing 1 to the right hand side. Now what next? Left hand side will continue to be same. On the right hand side we'll take LCM. This is 144. This is 169 minus 1 multiplied by 144 should give you 144. One more step involved over here is to simplify the right hand side. This is 144, and on subtracting this, what I'm getting? 25. Yeah, it should be 25. Now we can cancel with these two 144. As you can see, both side has the same denominator. So that results to give you x as what? 25. So we'll say that 25 is the answer for this part. Now in this question, we are given 2707 over under root x is equal to 27.07. Then what is the value of x? So what we need to do over here is to first shuffle this number. That means I'm going to bring this to the right hand side and this to the left hand side. So this way, what I can write over here, this will become 2707 over 27.07. The idea here is to isolate this under root x. Now what we can do in the next go is to remove this decimal and put 2 more zeros over here. So we know that this can be cancelled, right? So this can be cancelled by 100 times. So finally we got root x, right? We got 100 as root x, or we may write this root x is equal to 100. Now in order to remove this under root, what we are going to do is to squaring both sides. So on squaring both sides, root x, as you know that squaring a root number, the root vanishes, and square of 100 is what? There are two zeros in 100, so it should be 1 followed by 4 zeros. So we'll say that the value of x in this case is going to be 1 followed by 4 zeros. In the next question, it says if x over under root 2.25 is equal to 550, then the value of x. So what we are going to do in the first go is to find the square root of this. So what we know, or we should know in fact, that the square root of 225 is what? 15. But then we have here a decimal place. So for every two decimal place, we'll have one decimal place, right? So therefore we can say it is 1.5. So in the next go, what we are going to do, writing x as x and replacing this under root 2.25 with 1.5, which is equal to 550. Next is to get, in order to get x, I'm going to transpose this 1.5 on the other side. This is 1.5. I can remove this 0 decimal to write 10. This get cancelled. Finally, we are going to multiply this 55 with 15. Right. So we know that 15 multiplied by 55, if you calculate, you are going to get x as what? 825. Yes, so we say that we got the answer here, and the correct answer for x is 825. That should be the answer. Now the question over here is to find the least number that must be added to this number 753 so as to obtain a perfect square. And in the later part, we also have to find out the square root of the perfect square so obtained. Well, what we are going to do over here, as you know that in a question involving what must be added or subtracted, we use division method. So let's say if I proceed with the number, this is 7523. The first thing that we do is to pair these numbers from behind, right? Pairing from behind. And the first part, we will be looking for a number whose square is either 75 or lesser than that, or closer to this. So I know that 9 square is 81, which is bigger, and 8 square is 64. So 8 times is 64. We'll be adding 8 to this quotient. It is 16, and their difference is coming 1, 1. 2, 3 will be copied here. Now, next to this 6, we'll be placing one digit over here, which when multiplied by the same digit should come. Yeah, we are looking for a number bigger than this, right? So what must be added is the question. So we'll be looking for a number exactly slightly bigger than this. So this can be done by hit and trial method. Let's say if I multiply, if I replace this here as 5, what we are going to get is 25, 33, and 6, much smaller. Then we are going to replace this and let's multiply by 6 till we reach a number which is slightly bigger than this. So if I place 6 over here, it should come what? 996, right? It should be 996. Yeah. So that is 116 multiplied by 6 is 996. Still it is smaller. Then look for a bigger number. It should be 7 as we are going close to this. So if I multiply 167 with 7, so it should be 167 multiplied by 7 is, this is 49611. Yes, we got a number slightly bigger than this. So it's 1169. But then we have to find out the difference over here. So make sure you write this number first, the bigger one, and then the smaller one, so that you don't make mistake. 9 minus 3 is 6. 6 minus 2 is 4. Yeah. So 46 we'll say is the smallest number, right? So the least number here is 46. That must be added to this number so as to obtain a perfect square. And The 7 must be written over here also. The later part is also find the square root of the, also find the square root of the number. So the perfect square so obtained over here, the perfect square so obtained over here should be 87. This one. That's how we will do this question. Now next I have taken four questions of true false. The first question is the square root of 0.9 is 0.3. That's wrong, right? As you know that we don't have square root for odd decimal places, right? It's not a perfect square. Although the square root of 9 is 3, but the square root of 0.9 is not, right? It is not under root 0.3 for two reasons. Number one, you should know that the square root must have even decimal place. It has odd decimal place. And then if you, the other way you can also do, you can just reverse it. 0.3 into 0.3 is how much? 0.09, right? So therefore the square root of 0.09 is equal to 0.3 and not 0.9. So the first one is incorrect. That's wrong. Now looking for the next one. Next, it says that there are 200 natural numbers between 100 and 100 square and 101 square. That's correct. As I said, if you have n square and n plus 1 square, the total number of non-square number between these two is twice of n, that is 2 times n, right? That is, and over here is 2 times 100. 2 times 100 is what? 200. So it should be considered right. So this is a second one is a true statement, right? I should put a tick mark over here. Next says for an integer a cube is always greater than a square. It is true for positive, but not for all integers. Like for example, if I take 3, a number a as 3, you may say that a square is 9 and a cube is 27. So 27 is greater than 9. So you will say that a cube is greater than a square. But it is not true when I take this negative. Let's say if I take a as minus 3, a square, as you know, square of every number is positive. So minus 3 square is positive 9 over here. But when I take a cube from here, right? So the cube of minus 3, for cube of negative, it is negative. Now check here, a cube here, which is minus 27, is not greater. In fact, it is smaller than a square. It is smaller. So we'll say that as for that statement, this is a false statement. It should be written false for this part. Now checking for the last one. In the last part, it says the square root of a perfect square of n digits will have n plus 1 over 2 digit if n is odd. Yes, that's true. Like for example, if I take a 3-digit number, right? If I take a 3-digit number which is a perfect square, let's say if I take 1 to 1, which is a perfect square. So 3 plus 1. Now first I'll find its square, which is 11. So for a 3-digit number, the square root has 2 digits. So this is n plus 1, that is 3 plus 1 divided by 2, that is 4 divided by 2 is 2. That's a 2-digit number. You can verify with more such examples. So let me recall you the rule over here. If you have n, if you have n as an even number of digits, then the number of digits in the square root will be n divided by 2, right? That's for example, if I take 6-digit number, then its square root will have 3 digit. But for odd, right? For odd, the rule is n plus 1 divided by 2. For example, if I take, let's say, a 7-digit number, which is an odd over here, which is an odd over here, so that after finding the square root, it will have 7 plus 1 over 2, that is 8 over 2. It will have 4 digit. So that's the rule over here. So this is a correct statement. Now this question says the smallest number after 1, here 1 is the digit 1, which is a perfect square as well as perfect cube. So we can go for hit and trial method. 2 square is what? 4, but it's not a perfect cube. 3 square is 9, not a perfect cube. 4 square is 16, not a perfect cube. 5 square is 25, not a perfect cube. We keep on trying like this. 6 square is 36, not a perfect cube. 7 square 49, not a perfect cube. 8 square 64, yes. It is a perfect cube, right? It's a cube of a cube root, we can say 4 cube, right? It's a cube of 4, which is 64. Yes, so we can say that 64, right? After 1, the smallest number. There are more numbers, but we have to look for the smallest number, which is a perfect square as well as a perfect cube. So 64 is the correct answer. Next, I have taken 3 MCQ over here. The first MCQ says that the digit in the unit place in the cube of this. So we don't actually have to find the cube of this. Simply, we are going to find the cube of 7, right? Instead of finding the cube of 47, we'll be finding the cube of 7. So cube of 7 is what? 343. So it is, since it is ending with the digit 3, the cube of this will also end with the digit 3 over here, right? So the answer for the first part is what? 3, that is part C. Next is the least possible value of A. We have to get a least possible value of this digit number A, for which 90 multiplied by A is a perfect cube. Now, you can see among the options given over here, it should be multiplied with 90. As you know, for a perfect cube, there must be uh, 3 zeros or 6 zeros. And all these options has 2 zeros that multiplied by this 0 will give you 3 zeros. So we know that in every case, we are going to get a number ending with 3 zeros. Now, what we need to therefore check only, we need to check only this part. That is 9 multiplied by what? So 9 into 2 is 18, right? 9 multiplied by 2 is 18. 9 multiplied by 2 is 18, and it is not a perfect cube, so discard it. Similarly, we are going to multiply 9 with the first digit only 3. So 9 into 3 is how much? 27. 9 multiplied by 3 is what? 27, which is a perfect cube. So we can say that on multiplying this by replacing A with 300 should give you 27000, which is a perfect cube. Right, so the correct answer should be the option B over here. In the third part, we have to find out what? The largest 4-digit number, which is a perfect cube. Well, we know that 8000 is a perfect cube, but 8000 was what? Cube of 20, right? This is cube of 20, which is 8000. Now we must check for the next one, 21 cube. If you remember that 21 square is 441 and its cube is how much? 9261. So we can say that the correct answer is this, that is 9261, which is a largest 4-digit number, which is a perfect cube. Here we use a division method to find out the perfect cube on adding or subtracting. So in this question, we have to find the sum of this. But over here, we are not going to finding the sum by actually adding them. In fact, we are going to apply the rule over here that you can see that this is, we just need to count how many odd digits are there starting with 1, right? So it's 1, 2, then next is, let me first write down all the odd numbers before till to 25. So this is 11. Next number is 13. After that, it is 15 plus 17 plus 19 plus 21 plus 23 plus 25. So you just need to count these numbers and how many of them are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it should be equal to 13 square, that is 169. So what is that rule over here? You have to remember that sum of first n odd numbers, right? Sum of first n odd number is equal to n square. So it is not 25 square, right? It should be whatever the number of odd numbers are there, right? They're counting. So you can see that this is actually sum of first 13 odd number. So their sum will be equal to 13 square. We can take one more example to understand it better. Like say if I take, it has to start with first odd number, that is 1, 1, 3, 5. As you can see, it is three odd number, first three odd numbers. So its sum will be 3 square, that is 9. By actual adding also we are getting 9. And if I take like say 1, 3, 5, 7 plus 7, this is first four odd numbers. Their sum will be 4 square, first four, right? So four odd numbers, so that is 16. By actual addition also we are getting 16. So that's the rule over this. Now the next question says the unit digits of the square root of the following number will be either this dash or dash. That means we have to look for two such numbers, right? With which, or two such digits with which this square root of this will end. Well, we can do in a reverse manner also. We know that 2 square ends with 4. That implies that the square root of 4, a digit ending with 4 will give you 2. Similarly, we know that 8 square is also what? 64, that is ending with the digit 4. So we can say that even 64 square root will give you 8. So finally, we have to think in the reverse manner and we'll say that it is either 2 or 8. So we'll say 2 or 8 will be. We don't actually have to find out the square root of this number, right? Even if you are going to get, it says the unit digit of the square root of this following, right? So we are not going to get the square root of this number. The question over here is just to find out. So ordinarily, if I find its square root over here, we get 258. Well, it should be 8, but then we just have to figure out, since it is ending with the digit 4, then the square root of this number will end with the digit 2 or with the digit 8. This question says find the least number which is a perfect square and which is divisible by 6, 11, and 45. So there is two things. We have to get a perfect square and at the same time it should be divisible by these number. So let's deal with the first part. Forget about the square number. Let's find out the number, a number which is divisible by these three, a number which is divisible by 16, 18, and 45. So clearly a number which is divisible by these three number has to be the LCM of these. So let's say if I find the LCM of these numbers, the numbers are 16, 18, and 45. I'll go by 2 first. So it's 2 8 times, 2 9 times, and 45 is not divisible. Continuing to divide it by 2, so it will give you how much? This is 4 times. 9 is not divisible, 45 is also not. Continuing with 2 only, so this is 2 times, right? 2 times. 2 9 is again not divisible, 45 should come as it is. Next is one more time by 2. This is 1 times. 9 and 45 are not divisible. Next we'll go by 3, right? 3 1 time, sorry, 9 1, 9 3 times, and 9 15 times. Sorry, 3 15 times, what I'm saying. This is 1 time, and 5 times. Finally, by 5, what we are getting 1, 1, and 1. So we'll say now, since we are looking for the LCM, and we'll say that LCM of 18, 16, and 45. 16, 18, and 45 is what? Will be product of these. So it's how much? 2 into 2, 4 into 2, 8 into 2, 16. 16 into 3 is 48. And 48 into 3 is how much? 144. 144 into 5 is how much? 720. It is 720. Now check here, this is not a square number, right? This is not a square number, but then we have got a number which is divisible by these three, but that's not a square number. We have to make a square number. So in order to make a square number, you have to look for their doublets. We have a doublet of 2, we have a doublet of 2, we have a doublet of 3, 1, 5 is missing. So in case if I multiply this with 5, that should give you how much? 3600. So now you can see that 3600 is divisible by these three as it is a multiple of its LCM, and 3600 is a perfect square. As you can see from here, its prime factorization has uh, doublets of these numbers. So we know it's a perfect square. Therefore, we'll say that the final answer is the least number, which is a perfect square as well as divisible by these number is 3600. That should be the answer. Now this question says what? It says how many, question here is how many natural numbers lie between the square of 9 and square of 10. So whether it's a natural number or non-square number, whether it's a natural number or non-square number, it's the same. So the result over here will be twice of this, that is 2 into 9, that is 18. One more time, whenever we have to find non-square number between two consecutive square number, let's say if I take another question, 8 square and 9 square, so that there is a rule that it should be 2 multiplied by the first number. The number is 8 over here, that is 16. So in case if you are asked to find out how many non-square number or natural number are there between these two square number, then we'll say that is the square of the first. One more example I can take, 7 square and 8 square has to be consecutive number, natural number. So in this case, it will be twice of 7, that is 14 is the answer. So the rule is this only. That means if you have n square and the other is n plus 1 whole square, then it will be twice of this first number, that is 2n. That's the rule. Now this question says find the least number that must be subtracted from the number 3241 so as to obtain a perfect square number. And then we also have to find out the square root of the perfect square number so obtained. So what we are going to do is to apply the division method for finding the square root. So let's say if I take the number over here, that is 32, this is 3241. And then what we're going to do is to pair these numbers from behind. The next step is to look for a number whose square is either 32 or smaller than that. So we know that 4 square is 16, 5 square is 25, and 6 square is 36. 36 is bigger, so we'll take 5 square, which is 25. Now we'll add 5 to this quotient to get the new quotient as what? 10. And the difference is right. We'll be subtracting 25 from 32, that is 7. And we'll carry these numbers, which is in a pair, right? That's why we have placed a bar over it. It should come together. Now next to this 0, that means after 1 0, you'll have to think of a number which when replaced by that digit should give you either 77741 or a smaller than that. As you know, over here we have to look for a least number that has to be subtracted, right? In that case, we put a number which is smaller to this. Now let's say if I replace this number over here by 5, and if I multiply by 5, what do we get here? That is 525, right? 525, which is smaller than this. But then we have to verify by placing another number, say next to 5 is 6, right? So if I place 6, this is 636, still smaller than this. And if I place 7 over here, it's coming how much? 749. As we are looking for a number smaller than this, so we have to place this. So we can say that we are going to replace this by 6 multiplied by 6 should give you how much? 636. And then we need to find its difference. So we'll be subtracting this number. So from 741, we are going to subtract 636, right? So this is how much? 11 minus 6, which is 5. And this is 0, and this is 1, right? So 105 is the smallest number, which when subtracted with this will give you a perfect square. Right. So the required number we can say that has to be subtracted. That has to be subtracted is 105, and the perfect square number so obtained will be, we have to find out the square root of this whole number so obtained. So the square root of the number after subtracting 105 will be how much? 56.